Good day, class. Today, we will discuss the different types of sequences and series. And we will be solving for the term position and the sum of the terms of the different series and sequences. To start with, let us start with the first one, which is the arithmetic sequence. Okay. What do you mean by an arithmetic sequence? Arithmetic sequence is a sequence in which each term after the first term is obtained by adding a constant, and that constant is known as the common difference to the preceding term. So this is the formula for the arithmetic sequence if ever we need to get the specific term for the sequence. We have a sub n is equal to a sub 1 plus the quantity of n minus 1 times d, wherein your nth term will be the n here. Example, we are asked to get the 111th term. So that is our nth term. A1 will be your first term. Your n is the term position. Example, if our nth term is the 111th term, the term position here or your n will be 111. And then the d here is the common difference. And to get the common difference, we will subtract the second term to the first term. Take note also, class, that if the sequence is increasing, the common difference is positive. But if the sequence is decreasing, the common difference is negative. Next, for associated arithmetic series or sum of the terms, we have the following formula. S sub n, meaning the sum of the terms, is equal to n all over 2 times the quantity of a sub 1 plus a sub n. Again, n here represents the number of terms. A1 is your first term and a sub n will be your nth term. Nth term is also known as the last term if it is given in the problem. If your an is not given on the problem, we can also use this formula. S sub n is equal to n all over 2 times 2a sub 1 plus the quantity of n minus 1 times d. So it depends on the given problem whether which of the two will be used. Okay, let us proceed with the following examples. So take note of the following formula for arithmetic sequence and for solving the sum of the terms. Let's proceed with our first example. We need to find the 46th term of the arithmetic sequence 3, 8, 13, 18, and 23. So we are looking for the 46th term. Using the arithmetic sequence, automatically we will be using this formula later on. A sub n is equal to a sub 1 plus the quantity of n minus 1 times d. First, let us write the given values of our a sub n, a sub 1, n, and d. Then later on, we will substitute those values in this formula. Our first term or our a1 based from the given is of course 3. So we will write a sub 1 is equal to 3. Next, what is our n? Based from my explanation a while back, the n there will be the given term, which is the 46th term. So we will write n is equal to 46. Next, D. And D stands for the common difference. And just like what I've told you, to get the common difference, we will subtract the second term to our first term. So if this one, 8 minus 3 is 5. 13 minus 8, 5. 18 minus 13, this is still 5. And then 23 minus 18 is 5. Meaning to say, their common difference is 5. Can you follow? Next, A sub n. Our A sub n here is given. This is the last term. So our last term is 46 because we are looking for the 46th term. Meaning to say, our A sub n here is A46. But what should be the value of the 46th term? That is our problem today. So in order for us to solve for the value of A46, we will use now this formula. Let us rewrite the formula here in our solution. We have A sub n is equal to A sub 1 plus the quantity of n minus 1 times D. Let us now substitute for the following values here. Our A sub n is A46 because we are looking for the 46th term. That is our problem. A sub 1 is 3. Plus, your n is equal to 46. Minus 1, and then your D is 5 times 5. Okay, let us now simplify. A46 is equal to 3 plus 46 minus 1 is 45 times 5. A sub 46 is equal to 3 plus 45 times 5 is equal to 225. Okay, let us simplify. 3 plus 225. The 46th term in the given arithmetic sequence is 228. If you want to solve it manually, after 23 you can add 5. So 23 plus 5 and then plus 5 up to 46th term, you will still get the value of 228. But in order for us to compute easily, we will use this arithmetic sequence formula. Can you follow? Very good. Now let us proceed with our second problem. We are asked to find the sum of the first 46 term. So we will base the answer here from the solution that we obtained in our first example. So we are looking, or we need to find the sum of the first 46 term. And the formula to be used to get the sum will be S sub n is equal to n all over 2 times the quantity of A sub 1 plus A sub n. Okay, let us write first the value of our A sub 1. What is our A sub n? What is our n? So that we'll be able to substitute it later. Our A sub 1, based on our obtained solution, is, from here, we have 3. So we will write A sub 1 is equal to 3. Next, n is equal to 46. So we will write 46. And then, A46. We already solved for the 46th term. And the 46th term in this arithmetic sequence is 228. So we will write a sub 46 is equal to 228. Now let us write the formula for the associated arithmetic series or the sum of the terms in the form of S sub n is equal to n all over 2 times the quantity of a sub 1 plus a sub n. So we will now write S46 here, because we are now looking for the sum of the 46 terms. Our n is 46 divided by 2 times our a sub 1 is 3 plus our a sub n or the A46 is 228. This is the last term, the 46 terms. So we add the first term up to the 46th term. The answer will be S equal to 46. 46 divided by 2 is 23 times 3 plus 228 is 231. So the sum of the 46 terms will be 23 times 231 is 5,313. So when we add 3, 8, 13, 18, 23 up to 228, the sum will be 5,313. Okay. Next problem. Given 79, 75, 71, 67, and 63, we need to find a sub 32. The first thing that you need to do is to analyze. Is it decreasing or increasing? Yes, very good. It is decreasing. So meaning to say, our common difference here later will be negative. So that is how to get the specific term later on. Let us now first write the value of our a sub 1. A sub 1 based from the given is 79. So we will write a sub 1 is equal to 79. What is our n? N is the value that we are looking for. Our n is 32. So this will be our n, 32. The common difference is, so we will subtract. 75 minus 79 is negative 4. 71 minus 75, this is negative 4. 67 minus 71 is negative 4. 63 minus 67 is negative 4. Meaning to say the common difference is negative 4. And we are looking for the 32nd position. What is the value of a 32? So we will use the formula for arithmetic sequence, which is a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. Let us now substitute for the following values. Our a sub n here is a 32. Is equal to a sub 1 is 79 plus your n is 32 minus 1, and then your common difference is negative 4. A 32 is equal to 79 plus 32 minus 1, this is 31 times negative 4. 79, 31 times negative 4 is negative 124. So we will subtract. The value of the 32nd term is negative 45. The 32nd term here in this example or given is negative 45. So that is how to get the specific term. Next, what if we are asked to get the number of terms? Example, what is the term position or term number? Or how do we find the value of n? What if n is missing? Okay, let's take the last but not the least example. Given 79, 75, 71, 67, 63. What term is negative 169? What is the position or what is the term number of negative 169? Okay, first let us input the given values. Our a sub 1 is 79. N is missing because n represents the term number or the term position. So that will be our problem today. The common difference is negative 4. And then our a sub n, the given here is negative 169. Okay, we are now ready to compute. We will use the formula of the arithmetic sequence a sub n is equal to a sub 1 plus the quantity of n minus 1 times g. Substitute for the value of our an, which is negative 169. Is equal to our a sub 1 is 79 plus n is missing, so copy n minus 1, and then our d is negative 4. Let's compute. Negative 169 is equal to, copy 79, and then this part, we will distribute negative 4 to our n, and then negative 1 to our negative 4. So, negative 4 times n, that is negative 4n. Negative 4 times negative 1, that is positive 4. Next, simplify. Negative 169 is equal to 79 plus 4, our two constant, is equal to 83, minus 4n. Now, we will transpose negative 4n to the left, and then negative 169 to the right. So, it will become negative 4n will be positive 4n is equal to 83 remain. Negative 169, the sign will be positive. So, 4n is equal to 83 plus 169 is 252. And for us to get the value of n, we will divide both sides by 4. To eliminate 4 here, and n will remain. N now is equivalent to 252 divided by 4, that is 63. Meaning to say, class, negative 169 is the 63rd term in this given. Did you understand? Okay, very good. So that is arithmetic sequence. I hope you learned something for today. Thank you and God bless.